Banerjee, Assistant Professor from ECA Department at Rigid Education and Research Foundation Group of Institutions. Our today's topic is Fourier Transform. So, when we are talking about Fourier Transform, first we have to know what is transform is. Transform is what? The conversion of the domain. That means when we are talking about the conversion of domain, which have to conversion of domain means we can convert time domain to frequency domain as well as frequency domain to time domain. Frequency domain to time domain. That means why we actually did this type of transformation? For easy representation. For easy representation. Right? So, when we are talking about the Fourier transform, we have to change the time domain response to frequency domain response. For that, we have to analyze the spectrum of the signal. Spectrum of the signal. Now, the main equation of Fourier transform is x of j omega, that is equal to integration minus infinity to infinity x of t to the power minus j omega dt. Now the question is, what about x of t? X of t is nothing but the input of the signal, or which signal we have to check, right? That means when we are talking about the transformation, Fourier transform is help to convert the time domain to frequency domain response. So that is the input, or we can say the relevant signal, right? Which we have to convert in frequency domain. So we can write in this way also, x of j omega, rather we can write capital X of j omega, right? So here we can write capital X of j omega, that is the Fourier transform of x of t, right? That is the Fourier transform of x of t. Now, for better understand, we can write in this way also. Just a minute. For better understand, we can write in this way also. X of t is x of j of. Okay. So we have to know the existence of Fourier transform. When we are talking about the existence of Fourier transform, we have to remember that those signals we want to transform which have absolute integral properties. That means what? Minus infinity to infinity x of t dt is obviously less than or equal to 0, which is obviously a stable system. If it is not a stable system, we cannot transform it. So, those systems we want to convert it into frequency response, or we want to implement the Fourier transform of x of t, that we have to remember that the absolute integral of that signal which has to present, as well as the second property, that is one first property for the existence of Fourier transform, within finite time interval. And the third one is, it also has the finite number of discontinuity as a limit. So the third one is what? Finite number of discontinuity is also present. Finite number of discontinuity is also present within specific interval. Right? That is all about the existence of Fourier transform. So this three property, if a signal can satisfy this three property, then we can easily convert it, or we can easily transform it. Right? Now, the next one is what? That is a property. When we are talking about different properties of Fourier transform, we have to know that the properties which we are actually know in time domain, right? In time domain, when we are talking about the time domain, first we have to check the time shifting property. Right? Have to check the time shifting property. So for time shifting property, we all know that if a signal is x of t and I want to convert this signal as x of t minus of 1, that means it's nothing but a delay of the signal. Or if we check like x of t plus 1, that means nothing but the advance of the signal. Right? So I'm just considering that my signal is this x of t, that is a t, 0, this is 1 and 1. So the amplitude of the signal is 1. And I want to shifting this signal at t minus 1. What time shifting? So if it is x of t minus of 1 and if it is x of t, so the starting of the signal, the starting point of the signal is 0. That is the origin. And the range of the signal is 0 to 1. That means the ending of the signal is 1. But being we are shifting towards the right hand side for the delay purpose, so for 1, this signal is shifted 1 times from its original point. So this is my 1, 2 and this is my amplitude of the signal. Right? That is the shifting of the signal. Okay. So that is the time shifting property. And when we are talking about the time shifting property in the terms of Fourier transform, what they have to do, we have to check it first. Right? Shifting property. Fourier transform. Shifting property of Fourier transform. So we all know that remaining portion are same. Now, what we have to do with the signal? And what we have to do with the signal? Check. We can substitute the x of t minus t this way. Let t minus of t is equals to m, right? If t minus is equals to m, so small t is equals to m plus of t, right? And differentiate both hands, right? So dt is equals to d of m, because capital T is nothing but the constant, which is the derivative of the constant is equals to 0. We all know that. So the limit is same, because when t tends to minus infinity, so m tends to also minus infinity, and when t tends to plus infinity, that is also dm, or m tends to infinity. So the limit of the integration is as it is. Now we put m, right, instead of t minus of t, and e to the power minus j omega. What about the small t? That is m plus t. M plus capital T. And what about d of t? That is d of m. Clear? Now, check. This is the question. Okay. So what we have? Wait. Minus infinity x of m e to the power minus j omega m, and we can write e to the power minus j omega t in the form of indices or units, right? So check it with this form. We get x of m here, that is x of m, that is e to the power minus j of m, j omega m, and dm. Now check with this one, xm, compare that. Xm is equals to obviously x of t, e to the power minus j omega m is equals to j omega t, and d of m is equals to dt. That the position of the components, the position of the parameters are same with the upper one. But this term, that e to the minus j omega t, this is the constant term of us. So I'm just take it outside of the integration and put it like in this way, that is power minus j omega m d of m. Now we can write e to the minus j omega t, and what about this term? What about this term? This term is nothing but the j of omega. So x of j of omega, right? X of t minus t, that means the shifting property of Fourier transform. What we get, that e to the power minus omega t x of j of omega. That is the Fourier transform of shifting of time. Right? That is the shifting property of Fourier transform. Now we will check another property, that is the scaling property. We will check the scaling property, right? We know again x of t will imply Fourier transform will get j of omega Take the main formula, I am just writing in here. That is the natural formula of Fourier transform, right? So x of t is equal to minus j omega t dt, and instead of a we get x of a j minus of j omega m by a and dm. So m by a and dm we didn't get any kind of denominator here, right? But here we get m by a. Again, the thing is that when we are putting d of t, we have to put dm by a also. So I am just taking constant of this 1 by a and taking outside. So what about this one? What about this one? That is the, we have to write j of omega by a, because that is consists of m by a, right? So this is all about our scaling property of Fourier transform. So after scaling, what we get? After applying the Fourier transform, what we get is a scaling g of omega by a. Okay? I think this is clear for everyone. Thank you for joining us.